So we are on Unit 6, Chapter 11, Learning Objective 4, which is to distinguish between the different gas laws. So the first law that we talk about is Boyle's law. This relates pressure, it's abbreviated as P, and volume, which is abbreviated as V. The relationship between pressure and volume is inverse. So what this means is that as your volume increases, your pressure decreases. And as your volume decreases, your pressure increases. The graph for pressure and volume starts high, goes low, like that. Negative slope, all that good stuff. Now, in Boyle's law, you have two constants, which is temperature and the number of moles. The formula for Boyle's law is P1, V1 equals P2, V2. So where 1 is equal to initial and 2 is equal to final. So that is Boyle's law. Now, if you want a quick acronym to kind of remember that temperatures, so with Boyle's law, you just have to remember that the moles are constant, but to remember that temperature is constant, you can say I like BLTs. So Boyle's law, temperature is constant. So BLT for that one. The second law that we talk about is Charles's law. So Charles's law relates temperature and volume. So the type of relationship between temperature and volume is a direct relationship. So that means that the graph has a positive slope. So as temperature increases, you have an increase in volume. And as your temperature decreases, you have a decrease in volume. That's a direct relationship. Now, your constants here are pressure and the number of moles. And your formula for Charles's law is V1 over T1 is equal to V2 over T2. Now, I don't like this setup because it's kind of hard for me to follow. So essentially what I do, it's hard for me to solve. So essentially what I do is I move my T2 up and my V2 or my T2 up. So then this formula then becomes V1T2 is equal to V2T1. Now, you need to remember that 2 is going to go with 1. So my second temperature is going to go with my first volume, and my first temperature is going to go with my second volume. The other thing about this is that temperature has to be measured in Kelvin. So if it's given in Celsius, you have to convert it into Kelvin. And we'll talk more about why that is in just a little bit. So a memory technique for Charles's law: cheese, pizza. So Charles's law, again, moles is constant, but to remember that pressure is also constant, you can say cheese, pizza. So Charles' law, constant pressure. And then we have Gay-Lussac's law. This is going to relate pressure and temperature. The type of relationship is direct. It's got a direct relationship. We've already kind of talked about why it's a direct relationship in a previous learning objective. So the graph looks like that. So straight line, positive slope, all that good stuff. And so as temperature increases, we get an increase in pressure. And then as temperature decreases, we get a decrease in pressure. Constants here are volume and number of moles. Remember, number of moles is tied to your mass. It's also tied to the number of particles. So the formula for Gay-Lussac's law is P1 over T1 is equal to P2 over T2. Or again, moving these T values up into the opposite side so that we have a nice straight line. All we're having to do is divide for our unknown. So P1 T2 is equal to P2 T1. Again, your first pressure goes with your second temperature, and your second pressure goes with your first temperature. Something to remember this one by be green veggies. So green, Gay-Lussac's law, constant volume. So all of these, and again, so like these guys, so with the exception of the next one, which is Avogadro's law, in all of those cases, you have a constant number of moles. And then Avogadro's law is different. So in Avogadro's law, we don't have a constant number of moles. So he is different out of these four. Okay, so different. All the rest of them are the same. All of the other ones have a constant. So again, Boyle's law, Charles's law, and Gay-Lussac's laws all have a constant number of moles, which cause them to have kind of the same relationships here. So Avogadro's law relates the volume and the number of moles. The relationship between volume and number of moles is a direct relationship. So the only one that has a different relationship is pressure and volume. So again, as your number of moles increases, you have an increase in volume. As your number of moles decreases, you have a decrease in volume. Constants here are your pressure and your temperature. The formula for Avogadro's law is V1 over N1 is equal to V2 over N2. Again, you can move these N values up. V1 N2 is equal to V2 N1. Okay. And then there's two other laws. So that the next couple of learning objectives kind of talk about. One of them is the combined gas law. This is where we have taken Boyle's, Charles, and Gay-Lussac's laws and created a equation for that. So P1 V1 over T1 is equal to P2 V2 over T2. And then the other equation, that the other gas law, is the ideal gas law. And this is where we take pressure, volume, temperature, and the number of moles and put them all together. So this is PV equals nRT. Okay. Now, one thing to note here, and we'll talk more about those two gas laws a little bit later. In the next couple of learning objectives, we talk about the combined gas law and the ideal gas law. But one thing to note, and this is extremely important, is that anytime you have temperature values for any type of gas law, so any type of gas law calculation that you're doing, your temperature must be in Kelvin. So temperatures must be in Kelvin. If they're not in Kelvin, then you can have negative pressure values and you can't actually have negative pressure. You also cannot have negative volume. It's impossible. So the reason that it's in Kelvin is absolute. which means there's no negative values. So that was learning objective 4, which was to distinguish between different gas laws.